Hey everyone, and welcome back to class 3 of our Algebra 2 math class. Today is all about transformations of functions. Let's check out what's going to be happening. So objectives for today, we are going to look at how to transform a function. And it's kind of like Algebra 1 meets geometry in this case, because we did a ton of transformations in geometry, and you touched on them in Algebra 1. You sort of looked at different functions like linear, quadratic, exponential functions, and you got a little bit of an idea of how to manipulate them to suit your own needs. Now we're going to really look at it, and that is the meat of Algebra 2. What you will notice is that we will start this conversation about transformations, and then we will start looking at linear, quadratic, absolute value, exponential functions, and it will always come back to this idea of how do you transform it, what transformations have happened. When you look at the graph, how do you write the function that represents that graph, and that function is going to be, well, how did you take the original quadratic, cubic, exponential function and then transform it to look like the one in the graph? So it's all going to come back to this central idea. So this is going to be one of the most important lessons we do for the whole semester, and I'm glad it's recorded. Maybe put it on your schedule to come back to this a couple of times, or every time we start a new unit, maybe recap on this video. So video 3, very important video. So we're going to look at how do we change the parameters, so the variables in a function that will change basically its transformation, its position and its shape. And then we're going to identify some transformations from graphs. What do you need? Well, you're going to need to be able to answer, like, how do I reflect a function? How do I translate it? How do I do a stretch or compression? So what do I have to change in order to be able to do that? In our last video, just to recap, we talked about functions again, but how to identify when they're increasing and decreasing and writing the intervals for that. The average rate of change, so remember this is rate of change is slope. This is the average slope. So it's from the first point in the domain, the lowest, to the highest, and then what the slope is between those 2 points. And then positive, negative intervals, positive being when the range is above 0, and negative being when the range is below 0. So what values of x result in a y coordinate greater than 0? What values of x result in a y coordinate less than 0? So from algebra and geometry, let's do a quick recap. How many transformations can you remember? So a transformation is a way of changing a shape. What are some ways that you can change a shape? So try and list as many as you can in your head. Maybe pause the video and then come back and see how you did. All right, so we have translations, a slide, moving an object from one point to another where it does not turn, doesn't rotate, doesn't reflect, it stays orientated the same way. The definition being all points move in the same distance and direction as given by a vector. A rotation, all points move around a point by the same given angle in the same direction. Reflection, all points move over a line of reflection at 90-degree angle, the same distance to the line of reflection and the same distance past it. A dilation, all points grow or shrink by the same scale factor from a center of dilation. So everything gets bigger, everything gets smaller at the same scale factor, so the shape still looks the exact same, just a bigger or smaller version of it, the equivalent of zooming in or out. A stretch is when you're taking one dimension or one aspect of the shape and you are increasing it. So you think of making a shape wider or making it taller. Those would be stretches, as opposed to a dilation where it all grows at the same rate. And then a compression, opposite of a stretch, you're taking a dimension of the shape and making it smaller. So pinching something, shrinking the height down, but stays the same width. Those would be examples of compressions. In Algebra 1, so that was geometry. In Algebra 1, you did translations. Mostly, I'll come to this in a second, you did stretches and compressions as well. The stretch compression was mostly in linear functions where you talked about changing slope. You also did it a little bit in quadratics. So in the equation y equals mx plus b, the slope was actually a transformation. So like you were taking the original y equals x, so just an original linear function, it's called a parent function, and you were changing it. So the slope resulted in a stretch or compression based on the rise and the run. And then the b value, what effect did that have if you changed that? If you increased or decreased it, it moved it up or down. You ended up getting a translation up or down. And then for quadratics, you may or may not recognize this. A lot of times when we think of quadratics, like we think of ax squared plus bx plus c. So that is general form. In standard form, we did this because in standard form you could see the vertex coordinates, and then you could also tell if there was a stretch or a compression. So a vertical stretch or compression. So there was some transformations in what you were doing in Algebra 1, you just may not have known it. So a lot of this will look very familiar, some of it will not. So just be aware of that, like some parts you're gonna be like, oh, I knew that, and some parts you're gonna be like, oh, I did not know that, that's new. Make sure in whatever note-taking system you are using, you should still be taking notes, by the way, even if you are watching a video. Whatever note-taking system you are doing, you are writing the things down that are new information to you, or that you were like, I didn't remember that, but now I do. If it's reminding you, then that means your brain had said, okay, I didn't need to know that, I didn't remember it. So if it's familiar to you after like seeing it again, still write it down because your mind needs that reminder. All right, we are going to look at transformations of functions now. So geometry was all about shapes. This is going to be more about functions, so going into just the mathematical version. The original function, so whatever we start with, the pre-image, is going to be usually in the form f of x. It doesn't have to be, but that's going to be the most common thing to see. And then the transformed function, so in geometry that would be the image, is going to be a different letter, so a different function on the same domain, so of x. So f of x becomes g of x after a transformation. Now this is going to be the most important part of the slide today, this equation. So what you've got here is the transformed function g of x, and then the original function f of x is right here. So a, b, h, and k are all going to be parameters or variables that we can change that will result in a transformation happening to a function. So be aware of that. A, B, H, and K are all going to be things that we can change, and that will change the shape, the direction, the size of a function. Now what do they do? A is a vertical stretch or compression. So that will stretch or compress the function vertically, so along pretty much the y-coordinate. They will move closer or further away from the x-axis. If you make that a value negative, it will cause a reflection to happen. And you guys are going to see all this visually in a second. The b value, now notice it's 1 over b in the equation, not just b. So it's an inverse of what you think would happen. The b part is the stretch or compression. So if you see 1 over 2, it looks like a fraction of a half, but the b value is underneath. That would mean that there is a stretch horizontally of 2. So that is going to double the distance from the x-axis, or from the line of symmetry, wherever it is. If you make that negative, it will reflect it across the y-axis. The h value moves it left, right. That's your horizontal translation. And you may remember that from Algebra 1. To note, though, that negative. So that means that the opposite of what you think would happen is going to happen. So if you have x minus 5 in there, it will actually move it 5 units to the right. So it will increase the x-coordinate by 5. If you have x plus 2, it will move it 2 units to the left because it's going to be the opposite of whatever the h value is. So x plus 2 is really x minus negative 2. The h value is negative 2. So that's something that we saw in Algebra 1, but just remember that that was a weird situation that came up that confused a lot of people. And then k, the value at the end, is the one that moves it up or down. So just adding something to, so like all of this part is multiplied. If you think like, okay, that's going to be my y coordinate at the end of the day, if I am doing all this work and then adding or subtracting something to the end of it, it's going to add or subtract to the y value, which is going to have the effect of moving it up or down. So that very last step is what will move it up or down. It's a lot to take in. This is one I would make a flashcard for, or a poster or something, because there is so much important information on just this slide alone. What do all of those letters do? That is a very important question. You need to be able to answer that. So whatever method you need to, make sure you remember what parts of the equation do what. So then f of x, the original function, the ones we're going to deal with are x to the power of 1, which is a linear function, x squared, which is quadratic, x cubed, which is a cubic, b to the power of x, so that is an exponential function, absolute value of x, and sine x. We might look at cosine as well, but mostly sine. I guess let me... Okay, so parent functions, this is the function that when there's no transformations on it. So like if we just said f of x equals x, so that will be a linear function with no transformations on it. Same with x squared, x cubed, absolute value of x, b to the power of x sine x, like those are all examples. We're going to be transforming the parent function to become other functions. You're going to have to be able to identify those. Okay, so this is your first activity where I need you to pause the video and actually go do this. So you're going to go to student.desmos.com, you're going to type in the code V8HXN9, and please do this on a laptop or a tablet as opposed to a phone. You're going to need a larger screen, and you're going to need some of the functions that are not available on the mobile version. When you are done, come back and then continue on this video. So actually pause it, go do this, and then come back, because it's important that you do this before you see the next part of the video. Okay, so now, when you looked at those parameters, what did you notice? So in terms of how the function was manipulated, did you figure out, okay, A was going to make it taller or more compressed, like short and squat. Now the hard part with A and B is on most functions, the difference between a vertical stretch and a horizontal compression is very difficult to see, and in a lot of cases they're almost interchangeable. It's why when you were doing quadratics in Algebra 1, you just used A, x minus h squared plus k, because any vertical stretch or compression could also be described as a horizontal and vice versa. So we just didn't bother with B. And the difference between stretching something tall and thin versus pinching it, it looks the exact same. So that was the reason why, like in most cases, B just doesn't really matter that much. Now, when you look at the other functions, particularly the last one you did, that was the sine function. That's the one, that's often why I start with trig, because you can see all of the transformations on trig functions much better than you can on the other ones, because just the way the waves go, you can see, oh, I'm making it taller, I'm making it wider, versus like absolute value, quadratic, cubic even is not great. So look at that sine function, that last slide on Desmos, if you really want to kind of recap on what the different transformations do. We should be pretty familiar with h and k. Like h and k are going to be the coordinates of the key point in a graph. So when you talk about a quadratic, that's the vertex. So h and k will be the vertex point. When you were talking about absolute value, it'll be the vertex point. Cubic functions, the key point is actually at the center of symmetry, so it's in the middle there. So x and h will be that coordinate too. And then as you add different functions, like it will get different shapes, but the center of symmetry will always be the part that h and k talks about. And I just skipped over sine function, but sine function, the start of the function, the beginning of the wave is what the key point is. So the original function is the parent function. We've talked about that a couple of times, and then the transform function is g of x. So parent function is your input, g of x is your output, your pre-image and your image. So if we wanted to take a general function, and we don't even know what it is yet, like it's not, we don't know that it's linear, quadratic, exponential, anything, we just know that it's a function, a parent function, and we want to move it 3 units to the right. Which letter, which parameter do we need to change for that? So thinking back to, okay, which letter in the a times f of 1 over b, x minus h plus k, like which one is going to change the movement right to left? And hopefully you're like, oh, h. So if you want to change the horizontal value, you want to move it right or left, you're going to change the x coordinate, which is the h value. So we want to move it 3 units to the right. We need the h value to be positive 3. So then you go back to your original equation, and the other values, so the ones that are not being used, have to be identity values. So they have to be something that does not affect the value of an equation. So when you think about the identity value for multiplication, what can you multiply any number by that will not change its value? That is 1. So a and b, so multiplying or dividing, the identity value is 1. For adding or subtracting, it is 0. So that just means that if we're going to change the h value, that means k, we don't want anything to change vertically. So k is going to be 0, b is going to be 1, a is going to be 1. All their identity values, so they will not change the value of the function. They won't transform it in any way. So then we sub in that h value, leave the identity values for all the others. So that would leave us with g of x equals, so a is 1, so that's not going to change the value. So it's 1 times f of x, so it's just f of x. 1 over b, b is 1, so 1 over 1 is just 1, so it's not going to change anything. So we're parenthesis, x minus h is 3, that's what we were subbing in. So we get x minus 3, and then k is 0, so plus 0 doesn't affect it. So this is our new function, f of x minus 3. That's going to move everything on the original function 3 units to the right. If we wanted to move it 3 units to the left, it would have been x minus negative 3, which would have been x plus 3. All right, you guys try these. Stretch the function vertically by a factor of 5. Which parameter controls vertical stretching? And hopefully you're like, oh, a. So we're going to make the a value 5. So to stretch it by a factor of 5, you make the a value 5. So it's going to be 5 times the distance from the x-axis as it was. So that means a is going to be changed. We're going to put b to 1. So b is just going to be thought of as 1, h 0, k 0, because that's the only factor we're changing is a, and it's going to be 5. Rewrite our new equation. We get 5 times f of x. So whatever the old one was, we're multiplying the output by 5. All right, this time we want a horizontal compression by a factor of a quarter. So horizontal compression means that we are pinching everything in. So horizontal compression, on the horizontal view, we're going to move everything towards the x-axis or the center. So that's our b value is going to be a quarter. Everything else is either 0 or 1. And then you get 1 over a quarter. Remember, b is underneath a fraction. And 1 divided by a quarter is the same as how many quarters go into 1, and the answer is 4. So it will be f of 4x. So the difference between 5 on the outside and 4 on the inside is 4 is being multiplied by the x value. It's going to affect the x coordinate. 5 on the outside is going to affect the answer, which is the y coordinate. All right, example 4, reflect over the x-axis. So now that means we have to turn a or b negative to get that reflection. And the question is, well, which one is it? So if a controls the output answer, so the y coordinate, then by changing the y coordinate to positive or negative, it's going to reflect it over the x-axis. If you change what's inside the function, the b value, it will cause reflection over the y-axis because you're changing the x coordinate, but not necessarily the output. So all you need to do is make it a negative 1. So positive 1 is the identity value, negative 1 will have the reflection, but it will not stretch it or compress it in any way. And then reflection of the y, as I said, that would make the negative inside of the function, so it would be f of negative x. And if you think back to geometry, we would say if I want to reflect over the x-axis, then it would be x minus y. So remember our coordinate notations? So remember, you want the y-coordinate to become negative to reflect over the x-axis, and then if you want to go over the y-axis, it would be negative x, positive y. All right, pause the video and try and complete the 4 of these. So you're going to take a parent function f of x and you're going to put it through the given transformations. So write your answer in the form g of x is equal to, and then function. Off you go. All right, let's finish this off. So 4 units down, up down is the k value. So nothing else is changing. So it's just going to be f of x. Everything else is at its identity value. 4 down, if we want to move it down 4 units, it's going to be minus 4. 2 units to the left, so that's our h value. If left is going to be negative on the number line, so it's minus 2. So it's going to be g of x is f of x plus 2. And the reason it's plus is that would be x minus negative 2, and those two together become a plus. And then k value is still 0. Reflection over the y-axis. So we saw this one on the previous slide. G of x is f of minus x, because you want to make the x value negative as opposed to the y value. And then vertically stretch the function by a factor of 5. So we saw this one as well. G of x is equal to 5 times f of x. So this time we're given g of x equals 3 times f of x plus 7, and we're being asked, well, what transformations happened to f of x to get g of x? What do we do? So now this is just verbal, like what is it? If there's a 3 here, that's in the A position, and A controls stretches or compressions vertically. It is bigger than 1, which means that it's going to stretch it, so we have a vertical stretch by a factor of 3. F of x is the same, so there's nothing in there for b, there's nothing in there for h, but we have a k value of 7, and that is a translation up 7 units. So remember, up because k just is the literal, like if it's positive it goes up, negative it goes down. H is the one that's reversed. All right, what about here? F of x is that red quadratic, g of x is the blue. Quick tip for you, would be to look at the distance between different points and see are they the same. So if you look between the vertex and that first x unit over, it's over 1, up 1. Down here, it's also over 1, up 1. So there was nothing changed in terms of a vertical or horizontal compression. So it's the same quadratic, it's just in a different position. So that means we're talking about a translation. How do you go from 0, 0 to 3, negative 2? Well, you have to go right 3 units, down 2. So we would say we got to go right 3, down 2. Think about the letters they affect. Right 3, well, that's our h. Down 2, that's our k. So g of x is f of x. Now we want to go right 3, so it's going to be x minus a positive 3, and then down 2 minus 2. Let me erase this so you can see it. Okay, so now just assuming that instead of just basic f of x, this was f of x is x squared. So the parent function is x squared. Well, that would just be the exact same thing. We would say g of x is equal to no stretch or compression, so f of x. And we said we want to go 3 units to the right, so x minus 3. The only difference is it's squared, minus 2. Had this been an x cubed, we'd replace the 2 with a 3. If it was an absolute value function, the parentheses would be vertical instead of parentheses. Like it's almost going to be the same process for every single function we do, which is the nice thing. That's why we're kind of talking about it in general terms first, and then we're going to go specific. All right, we're almost at the end. Your turn. Take a shot at these, pause the video, come back and see how you did. Question 3 is the one that uses the graphic. 1 and 2 do not use the graphic. Off you go. Okay, welcome back. Identify the transformations. So we have negative a half. So negative means that there was a reflection. It's outside of the f of x part, so it's going to affect the y value. So reflection that changes the y value, that's a reflection over the x-axis. We've got a half, the a value is a half, so that is a vertical compression because it's less than 1. That's a half. We have a plus 2, so x minus h equals plus 2. So minus h is positive 2, which means h is negative 2. So that means that we went translation 2 units left, and there's also a k value, so it's still a translation. 2 units left, and it's a minus 5, so we're going 5 down. Now that was a more challenging one than we'd seen so far. Like there was a lot of combos in there. Hopefully you recognized all of those. If not, maybe try it again. Make up your own one. Just like throw down a random function and see can you identify what the transformations were. Just like first thing that comes into your head, go. You could also look in your textbook for some extra examples when we're done with this. All right, number 2, identify the transformations on the given function. We've got f. So there's nothing in the a spot, so no vertical ones, but there is something in the b spot. And remember, it's 1 over b, so that means b is 3. So that is a horizontal. 3 is larger than 1, so it's a horizontal stretch by a scale factor of 3. X minus h, so h is negative 1, so it's going to be translation left 1 unit, and then we've got a plus 3, so left 1 unit and up 3. All right, looking at number 3. Now this is definitely the hardest one on the set of problems here. We've got the function f of x up top, g of x down low. I gave you a coordinate to show you, okay, what happened. So we went over 1, up 1. So slope of 1 over 1. In this one, if we go over 1, so from negative 2 down, it's only going down a half. So it's over 1 down a half. So that means the run stayed the same 1, but the rise is half of what it was, and we've got a reflection. So if you're affecting the rise, that is the y coordinate, that's a vertical component. So the a value is going to change, and we're making it smaller, so it's a compression. So we've got a vertical compression of a half. It also reflected over the x-axis. And we've got a translation because if we had just done that, the vertex would still be up here. So it's also been translated down 2 units. And now you got to write all of that as a function because it did ask you write the function. So g of x, we said reflection, so negative a, compression of a half, negative a half, times f of, there was no horizontal translation or horizontal compression or stretch, so b is fine, h is fine, so it's just f of x, and then down to minus 2. That was definitely a more challenging one. If you have problems with that, bring it up in the live classes so we can go through more, or we'll probably go through more anyway. All right, that takes us to the end of today. What do I need to change about a parent function to reflect it? Well, you're going to change the a or the b value depending on which axis you want to reflect over. Make sure you are recapping on what each of those parameters do. That is that slide where it shows all of the transformation parameters and what they do. That's the one you need to memorize. Make a poster of it, get that into your head. If you want to translate it, you're going to change the h or the k value. Remember, h is the inverse of what you think. So if you want to go left, you are going to add to x. If you want to go right, you're going to subtract from x. And then stretch or compression, that's our a and our b values again. Anything greater than 1 will stretch it. Anything between 0 and 1 will compress it. So thinking like in terms of percentages, over 100% gets bigger, between 0 and 100 makes it smaller. Negatives will add that reflection in, so just be careful with that. All right, at the end of this, you should be able to finish that last folder in Unit 1, Module 1. It's called Transformations of Functions. You started with this video. You should be able to go all the way down through the final lesson. And that means you have completed this module. So you should be able to go do the math tasks and then our final quiz. And I believe I will have given you details about that in class by now. Talk to you soon.